Well, thank you everyone for having me. Actually, I have no idea how many people we have in the session, but it's good to be virtually in Manchester, and I've never been there in person, so I'm looking forward to be amazed by all these curry restaurants. Probably too much to try them out all anyway in a lifetime, but yeah. So what I'm going to talk about is feature or an attribute of Power BI that is not too well known, I've experienced. And actually, I've just recently learned about the name of this feature. So, and that's the feature AutoExist. Well, this one slide. Let me go here. Yeah, there we go. So this is me, Michiel Rozema. You had it almost correct. Yeah, I worked at Microsoft for a while. I'm now a Power BI consultant, trainer, and founder of the Dutch Power BI user group, board member of the same thing. Yeah, well, you see my contact details, a couple of URLs, so please feel free to connect with me on LinkedIn if you want to do that. Okay. Let's start with a couple of, a little bit of theory, and after that I want to dive into a practical example. So I have a couple of slides and then we go to Power BI Desktop and play around there. But let me first explain to you what AutoExist is. And by doing that, I have to start with the concept of filters. You should actually be quite familiar with filters because that is all that Power BI is about. It is one of the most fundamental things in Power BI, both on the side of visuals and also in DAX, and the two interact with each other as well. So there's a little picture here on the slide explains to you that your visuals in the report, they produce all kinds of filters. The filters create a filter context, and context, as we all probably know, is a fundamental thing to understand if you want to learn DAX and want to understand what your DAX calculations do. So that's the importance of filters. Now, what is a filter exactly? So starting off from a Power BI visualization, a filter you could say is a selection of a couple of values in one single column of the model. And you can have all types of ways to create filters in your Power BI report. You can use the filter pane, of course. If you have a slicer, you make a selection there, you create a filter, and basically everything in a visual, labels, axes, legends, everything returns a filter. Now, if you work with a Power BI visual, a Power BI report is actually quite easy to find out which filters are active at one time. Let me switch shortly to just an example Power BI report. You can see here a couple of charts, and we have a couple of slicers, and in my filter panel I also have a couple of filters there. Now, you probably have seen this little funnel icon at the top of a chart, and there you can see exactly which filters are active on this visual as a whole. So that doesn't include the filters that are coming from the x-axis, for instance, and other elements in the visual itself. What you also can see here is that you can have multiple filters on the same column at the same time. Like for instance, in this case, we have two filters on the column year, and one filter says, okay, we select 2020, and the other one says we select everything except 2017. Right, so and understanding which filters there are, which are active at, for a certain data point in visual, helps you to understand what your calculation does and how it works. Okay, let me go back to the slide here. Right, so that is what a filter is. Now, the AutoExist feature of Power BI, it's actually quite simple to explain what it is and what it does. The reason that we have AutoExist in Power BI is that the Power BI engine tries to optimize the number of calculations needed to return results to a specific visual. If you have worked with DAX, you know that context is very important to understand what the results of a calculation are. But there's one other level that says, okay, but what calculations are performed for a visual? And AutoExist controls the number of calculations. Now, if you have a couple of filters on columns and you use multiple columns in your visual, or you have multiple filters on multiple columns, then AutoExist says that as long as these filters are on columns in the same table, Power BI will only evaluate combinations of values that can be found in that table together. Right. Small example: if you use a column name from the customer table, you use the column segment from the customer table, and say, for instance, that let's say Nike is a customer in the enterprise segment and not in the small business segment, then Power BI will never evaluate calculations for Nike and small business. So that is what AutoExist does. On the other hand, if you use columns from different tables, it works in a different way. Then Power BI will evaluate every combination of values in these columns. So if you have moved your segment information to a different table, and Nike is still a customer, and enterprise is still a segment, and you may even have a relationship between the customer table and your segment table, then even when Nike is connected to that enterprise segment, still Power BI would also evaluate Nike in combination with small business if your filter on the segment table selects small business as well. And that is quite a fundamental thing to understand working with Power BI models. Let me quickly show you the effect of this. I here have an example of a table visual with two columns as labels, and the third column is actually a measure, so a calculated result. So if we have the column name and the column product, let's say that we have 150 unique values in the name column, and let's say a lot more values in the product column, 32,000. If these two columns come from the same table, well, then 32,000 is the maximum that you can have. Well, that's not actually true, because you may have even different rows with the same product value and different name value, so it might be slightly different, but it's likely kept to on the maximum of the rows of the table itself. But would we take these two columns from different tables, then you get actually 150 times 32,000 values that are evaluated. And if I made my calculation correctly, which I hope I have done, then it's about 4.8 million combinations, which sounds a lot. Now, to be honest, the difference for Power BI is not that big. 4.8 million calculations performed, well, is not a big deal all the time for Power BI. It really depends on the efficiency of the calculations that you do. But you can imagine that if you have a table and you keep adding columns from different tables to that table visual, then the total number of calculations needed to be done to populate this visual it increases exponentially. So it could reach billions and billions of calculations to be done, and especially if your DAX formulas are less efficient, then this is a common cause of performance problems. So this is something to understand, that this happens. So if you have performance problems in your reports, this may be one of the causes of that. And by the way, this is a reason why I'm absolutely no fan of table visuals in Power BI. From this visual, you can actually see that Power BI is designed to produce visual reports. If you stick with the charts, column charts and line charts, and what do we have, then everything is fine. But the moment you start using table visuals, then you run into trouble. Yeah. So typically what I do when designing Power BI reports is keep things visual as long as possible, and only when zooming in or drilling through to only small data sets, then I tend to use a table visual if my customer really wants to do that. All right, so so that is the theory about AutoExist. Now you may think, well, okay, it happens, it works that way. I could avoid having too many columns from different tables in my visual. But if you know how AutoExist works, how it functions, then you can actually do very nice analysis on your data that are, well, quite hard to do otherwise. And what I want to do in the rest of this session is actually guide you through a practical example where we encounter AutoExist in a, well, maybe surprising way. So what I'm going to do is switch over to Power BI Desktop again, and let me first go to my model diagram. As you see, this is well, very complicated model, and we have two tables. Well, in reality, we have a bit more, but this is what we really need. We have a fact table with sales records. I will expand that for a bit, with things like sales price and costs and stuff. And we have a relationship to a calendar table or a day table, which I hope you all have in your Power BI models as well. So what we can do with this is, of course, do some aggregation over my sales table and create some reports on sales and do some time-based analysis. Now we have a very particular customer here. It's well, basically where we go here. If you look at just the basic chart of sales or daily orders, then you will notice that we, well, our business is only open during weekdays. So in the weekends we have we spend time on other things. So only, yeah, the only days that orders are taken in are the work days. And the result of that is a chart like this, where you obviously only see results on that on the work days. Okay, now this is nice, but as you will probably all know, the first thing you would like to see here is, well, an order amount by day. That is interesting, but what we really want to know is how are we doing for the whole month. And obviously on a higher level, how are we doing on the on the whole year. Oh, sorry for that. Okay, so what I do is I create a simple month-to-date measure, and I will show you how it works here. Yeah, I have my base sales, which is basically the chart that you see here, and with a simple calculate and our dates month-to-date function, you can create a month-to-date result. You could also use the same the total month-to-date function, which is a little easier to write, but I like to do it this way. So, but it doesn't really matter. Now, let's put this this measure in the chart, and I'll put that down as a line value. And there we go. Here we have our month-to-date total. Now, of course, we don't do any business in during the weekends, so our month-to-date line is horizontal during all weekends. That is kind of annoying. If I want to do some analysis on, okay, how are we doing with respect to order intake, that's not a very nice line to work with. So what I would like to do is change this chart a bit and say, okay, we don't want the weekends to show at all. Right? Well, that is easy. If I go to my calendar table, there we go. Then what I have done is I created a column called Workday, and that column contains a 1 for every date that is a workday and a 0 for every day that is in a weekend. If you have bank holidays, you can use them as well, but we'll keep it simple for now. So what I do is simply I say, okay, I'll go to my filter panel. Actually, I have already added my workday column to the filters. So what I can do here is say, okay, I only select the ones here. And apparently nothing happens. Yeah, and that is because we need to do one other thing. Because if you use a numeric data type on an axis, then Power BI will say, okay, this looks like something we can create a nice axis on, and we call that a continuous axis, meaning that it will distribute the values on the axis in the most logical way. Well, we don't want to do that now, so we change this continuous type into categorical, and then you will see that we get rid of the weekends altogether. All right, so well, very straightforward. You can use that to do that. Now, I want to go one step further and say, let me add some comparisons on how are we doing on this month versus the previous month. So how was last month's order intake in relation to this one? Now, if you have worked with time intelligence functions before, you probably know how to do that. I will switch to another page, by the way, because I just to be sure I created everything here. So, okay, there we go. It's basically the same chart. The thing that I changed is, well, I removed the order amount by day. This is still the same line. And the other thing that I did was I changed the date on the axis by a number. Well, what is that number? That number is the workday number in the month. Yeah, so we're looking at June 2020, and June 2020 happens to have 22 workdays. So we want those workdays on the axis here. Okay, now let me show you the formula for orders last month. There we go. So I'll take that orders month to date measure as my starting point, and I apply again a standard time intelligence function on that to move the context on the calendar 1 month to the past, and I do that by date add with -1 month. Yeah. So doing that, and when I look at the month of June, this will cause the context for this calculation to shift to the month of May. And that is exactly what we want to do here. Okay, let me add that to the chart and see how it looks. There we go. Now again, this doesn't really look very nice, right? It is kind of a strange line. And if you think about it, well, it may happen that last month sales were a bit bumpy, but actually, if you think about it, then simply going 1 month back in time, let's look at this one, for instance, the 7th workday of June is, well, what could it be? Maybe the 8th of June or the 9th of June. If you go back 1 month, then we end up in the 8th or 9th of May, and that may well be a weekend. And as we have seen previously, our charts in weekends are horizontal, and that is exactly what you see here. You will see these horizontal pieces, sections of the chart again. So this is not really what we want to happen. And actually, this is an interesting example where our standard built-in time intelligence functions don't really do what we want them to do. And there's really only one solution to that, and that is that we have to build this without time intelligence, and we're on our own there. So we're going to do that, and I'll have my, which one is it? There. I have another measure called order last month workdays. Now let's look at this formula and see what it does exactly. It's a bit longer. It's not as long as the formulas that Chris showed in his session. So I think I'm able to talk you through it completely. So if you think about what the month or the date add that we want to have, what it does is it looks at all the dates and subtracts 1 month. Now there is one very nice thing about the time intelligence functions in Power BI. Or actually, they leverage the way Power BI encodes the dates in your model. It's really only a number. You probably know that it's the same as in Excel. So we start at 1 for 1st of January 1900, if I'm correct, and then every day adds 1 to this number. So that makes it very easy to move around in the calendar. What is complicated actually is that, of course, our calendar is kind of chaotic when it comes to number of days per month. But okay, what we have to do here is determine what is the month that we're looking at, and how do we get at the previous month in the right way. And we need 2 things here. Let me go back to the calendar table once again. because to make things easy, I've created two columns here. One is the counter of the workday in month. I already showed you that using on the x-axis. And the other thing that I did was create a month counter column, which is this one, which is basically a counter that well, starts at 1 in my calendar table, and each month it adds 1. So that makes it easy. If I subtract 1 from that counter, then I end up in the previous month without having to worry about ending up in another year, for instance. Okay, so what I do, I create first a variable. I call this variable this month, and what it says is really the give me the largest value of the month counter column in our current context, of course. And also I create another variable called max workday, or what is the largest workday number that we see in our current context. It's this one. And with these two variables, we start calculating. So I use that orders month to date measure. But before doing that, I say, okay, but instead of our current context, I want the context to be the month counter is 1 less than what we were looking at. And we want the workday in month to be, well, the same one as what we were looking at. So meaning that if we start with, for instance, workday 11 in June, then we end up in workday 11 in the month of May. Now let's see what this does. What's this one? There we go. Now I'll remove that month to date for a bit. So this is the comparison between my standard previous month line using the date add function. That's the red one here. Sorry, that's the green one. You see the bumps there, and the red one is the new measure. And indeed, you see that that the weekends now are not counted, and we get a nice smooth line. Yeah, so we're not comparing date to date, but workday to workday to the previous month, which actually makes sense if you think about it. So month to date back. Let's get rid of that previous one. So, okay, well, now we have a nice chart with the month to date orders in June and the month to date orders in the previous month. What you see, by the way, is that in June we have 22 workdays. In May, we have only 21 workdays. And that's how our calendar works. Yeah, each month can have a different number of workdays in it. So everything nice and fine. Now we have a problem here. And you cannot see that here, but let's look at some other months here. For instance, go to May. We already know what that looks like because that's the red line. It will now become the green line. And there in red, now we have the results for April. Now, what you see is expected. May only ends up or goes to workday 21. So this still looks okay. If we go back to April, this is the chart for April. Hey, and now we have a problem because now we see workday 22. So April, which is the green one here, actually does have a result for workday 22. If we go to May here, we don't have anything for workday 22. Yeah. So we're missing data in this chart. And we know it's there, but it's not shown by the Power BI visual. Now this, ladies and gentlemen, is the result of the AutoExist feature of Power BI. Because what happens if you look at what we have here, well, let's not look at that, it's a bit much. Yeah. Okay. If you look at the filters that are active in this chart, then we have a couple. We have year, the year 2020. We have the month, which is the month of May, and we have the workday number. And all three columns come from the same calendar table. And remember what AutoExist does. It now will only evaluate combinations of values within these selections that are actually found in the calendar table. So if we look at the part of the calendar table corresponding to the month of May 2020, then we will find that we only have workdays 1 to 21 there. If you don't believe me, let's do that. So select 2020 here, select the month of May. And there we have everything up to 21. Yeah, it looks a bit strange because I numbered the weekends also with the same workday number, just in case. But we have only 21 workdays. So Power BI frankly doesn't care that your measures return results for something else. It just says, okay, this is what I've got. So I really don't need to calculate more than what I have to work with here. Yeah, so this is really a problem. If you don't know about AutoExist, it's actually quite a puzzle to find out why you're missing any results in this chart. Yeah. Interesting question, of course, is how to solve this. And actually, this the solution is fairly simple. The only thing we have to do is make sure that the workday counter is not taken from the calendar table, but is taken from another table. Yeah. So what I do is I create another table in my model. There we go. And I create a simple workday table with just one column. Now, if you want to see what's in that table, it's really very simple. It's the numbers 1 to 23. And I've done the math. No month has more than 23 workdays, so this is okay. I have also created a relationship from the calendar table to the workday table. Because if I have, again, if I select May 2020 and I say I want workday 15, for instance, then we need to know, Power BI needs to know which dates correspond to that selection. Yeah? So having this relationship here, make sure that we can do that. Okay, now what I'm going to do is first change the workday values on the axis here, which is taken from the calendar table. I will change that to the same data from that workday table. There we go. One of the most annoying things in Power BI visuals is that it messes up the sort order. So I have to say I want to sort by workday a month, and still I want to sort that ascending. So now we're going back, right? Now to make it work, I have to also change my my measure for the last month orders, because I work now with workdays column in a different table, and I use let's see, this one. I'm not very creative. I call it orders last month workdays 2. And what I change here is simply I calculate that variable max workday by taking the value from the new workday table instead of the calendar table. Yeah. And at the same time, in our calculate statement, we don't have a filter argument saying the workday in the workday table should be that number and not only in our calendar table. Yeah, so this is typically how you would do that. Okay, so I remove this one and go to my workdays 2 here. So the results in June are still correct, but the results in May are still wrong. That's kind of dissatisfying, right? So we have now done the work to actually take that workday column from our calendar table to make sure that weekday or workday 22 is evaluated in combination with May 2020. And actually it does, but apparently we don't get any results for that combination of filters. So that's actually the last thing to find out. Why don't we get any results on our on this last workday in May? Now let's take a look at our measure once again, because the problem here is not in using our workday table. The problem is really in the first variable in this case, and I've taken this specifically to explain to you what you will run into if you start working with these concepts. Look at this first variable. It is a variable, it's an expression. We still take the max calendar month counter. But this expression is evaluated in the context in which the measure is calculated. So, and in this context, we have to deal with all the filters that are active in this context. Now, remember what filters did we have? We had year 2020. We had month is May, and we had, on the point that we expect, we have workday 22. Yeah. And we have a relationship from filtering from the workday table to the calendar table. That means that overall, these 3 filters cause no row at all being selected in the calendar table, because there's simply no row in calendar that satisfies those 3 filters. And that means that the value for our variable this month is simply blank. Yeah. So it is being calculated for this data point, but the variable is blank. Now, if you look at the calculate statement again, well, where do we use this variable? Well, you see here in row 8. And then we say, okay, calendar month counter should be this month -1. Well, this month is blank, and if I say blank -1, then Power BI translates blank to 0. Or what do I get? My new context says, give me orders month to date, the value of orders month to date for calendar month counter is -1. And again, in our calendar table, we don't have any row where month counter is -1 because we started counting it at +1. Yeah, so again, we have an empty context to calculate our month-to-date order value. And obviously that results in a blank result for this measure. So the reason that we don't see any result for workday 22 here is a totally different reason than before. So before, the reason was AutoExist blocks evaluating workday 22 in total. And now we don't get a result for 22 because the result is blank. And blank values are typically not shown in a Power BI visual. So what do we have to do? And that is my last measure, workdays 3. There we go. Almost the same, but I have to fix this problem in my first variable. So and if you think about it, it doesn't really care what workday exactly we have selected. We're really interested in that month counter value. Yeah, so I can simply erase the filter on workday, which I do by all workday here. Yeah. And that way, the calendar will not be filtered by that workday selection anymore. And now we will have correctly calculated this month, being the month of May, for instance, and we will get a correct result from our measure. So let's look at how that looks here. Workdays 3. There we go. And now you see that we have indeed, whereas our normal month-to-date line ends at workday 21, our previous month line ends at workday 22. And that is exactly what we want to have. Okay, so I'm going to wrap up the conclusion, and I hope that the thing that you take away from this session is that when working with DAX calculations and DAX measures in visuals, not only the filter context is very, very, very important to understand, but it's also important to take into account what combinations of filters I induce by adding columns to my visual or to my report page or wherever I have them. So be aware of what happens. Be aware of the number of calculations that you force Power BI to do, to perform. Well, in some cases, you will run really into, well, trouble or confusion. And then understanding AutoExist is what you need to solve those. And with that, I thank you very much for this time, and I think I'll head back to Ben.
Brilliant. Thank you, Michiel. Sorry, just have a little drink there. So just as we thought we're getting our heads around calendars, you introduce a whole different set of issues that we might have in this particular scenario, where your different months, of course, have different working days in there. And of course, the answer is just to get everybody to work in weeks, right?
Well, yeah. That's okay, but you should stop using time intelligence functions totally. So it can be done. It can be done.
Yeah, no, a massively a difficult problem to solve. I can only imagine how much time you actually spent trying to figure that one out and resolve that. I've just had a quick look. Of course, there is SQL BI, not that, well, no, I do like those guys, of course. They've got a whole article on understanding DAX AutoExist, so that would be a good follow-up from this. session as well. And
yeah, actually, I just finished a small blog series about this particular topic. So if you head to my blog site, you can read that through.
Just remind us of the URL for that, would you please, Michiel?
Sorry?
Would you remind us of the URL for that?
Yes,
put your socials on the web there.
There we go. This is www.quantoblog.eu.